Hello and welcome to the 8th video lecture of Operations Research Semester 4 Module number 3. In today's video lecture we are gonna talk about finding IBFS, that is Initial Basic Feasible Solution of a Transportation Problem using Northwest Corner method. In a previous video lecture we have seen that any transportation model consists of two phases, phase 1 or stage 1 and phase 2 or stage 2. First, any transportation problem that is given to you, you have to first do stage 1, and stage 1 can be done through any of the three methods, that is Northwest Corner method, matrix minima method or Vogel's approximation method. In today's video lecture we are going to see Northwest Corner method. Northwest Corner method, also known as Northwest Corner rule or Dent's method. It is abbreviated as NWCM or NWCR, depends upon what you're gonna call it, whether Northwest Corner method or Northwest Corner rule. It is used to find the initial basic feasible solution, that is stage 1 of a transportation problem. The transportation problem looks like this. So this is the first problem that we are going to deal with. The problem states like this: determine the IBFS, that is initial basic feasible solution, using Northwest Corner rule, and a matrix is given to you. Generally we have transportation problem in the form of a matrix in your question paper. At the top here you have destination, and on the left hand side you have sources. This is always demand and this is supply. So this is how your matrix, any transportation matrix, looks like. It is a box kind of a thing. Here destination, that is the first destination D1 you can say, the second destination D2, the third destination D3, and so on, D4, D5, D6, any number of destinations you can have. And then you have supply sources, that is S1, S2, S3, S4, S5, so on. So this is how your structure looks like of a transportation model. Now coming to this problem consists of three destinations here, that is 1, 2 and 3, and three sources A, B and C. Normally if you google, if you do not know the meaning of source and destination, you can google it out. Source is the starting point always. So what happens is your units, that is your whatever items you have, you are going to transport from these sources towards these destinations. And what is the meaning of this cells or matrix? I'll tell you. If you want to transport 1 unit of item, that is maybe 1 kg, 1 liter, one number of item. So if you want to transport 1 unit of an item from A to 1, that is from source A to destination 1, it will cost you 2 rupees or $2, whatever currency it is. I hope you are understanding. Similarly, if you want to transport 1 unit of item from source C to destination say 2, it will cost you 6 rupees or $6. Fine. So these are the unit transportation cost what is given here. I'll rub this off. So whatever is there inside here, all these are unit transportation costs of transporting materials from sources A, B and C towards destinations 1, 2 and 3. Sources is the initial part, that is sources will always have supply. Sources supply items to destinations. So in this problem it says that source A, see before that I'll tell you one more thing. I have told you that these are the unit transportation cost. So inside whatever you have in the matrix are transportation cost related to unit items, that is individual items or one item. Supply source A has a total supply of 10 units. Similarly, supply source B has a total supply of 35 units and supply source C has a total supply of 25 units. Similarly, destination 1 requires, that is requirement or demand, is 20 units. Destination 2 has a total demand of 25 units and destination 3 has a total demand of 25 units. So this is how your problem stacks. All matrices of should be in this format itself in transportation method. That is, you have a set of sources, you have on the left hand side, you have a set of destinations on the right hand side, sorry, on the top. Destinations D1, D2, D3 are written there and so on. Sources A, B and C are written here on the left hand side row wise, and inside that are unit transportation costs. The supply of source A, total supply, that is maximum supply source A can supply, is written here. Maximum that source B can supply is written here. Maximum that source C can supply is written here. Similarly, destination maximum what they can provide is written here, or sorry, what is required is written here. D2 whatever is the demand is written here. D3 whatever is the demand is written here. It is similar to an example I'll give you. Suppose you want 1 kg of rice and you go to a shop, that is your home requires 1 kg of rice and you go to a shop. The shop has 10 kgs of rice. The shopkeeper will give you 1 kg of rice. So when he gives 1 kg of rice, the rice moves from the shop to your home, right? 1 kg of rice moves from the shop to your home. So your shop is your source and home is your destination. So from source it moves towards destination, always remember, from source to destination always. So this is the format of your transportation problem. Now let us see how to solve this transportation problem using northwest corner rule. This matrice will be given to you in the examination and they will ask you to solve using northwest corner method. This can come for 5 marks in part B. Determine the IBFS using northwest corner rule and a matrice is given. So whenever in transportation problem, the first step, if you want to solve or before solving, you have to check whether the given problem is balanced or not. That is, whether the given problem is balanced or unbalanced. If the given problem is balanced, we should have total supply should be equal to total demand. So we'll first see what is the total supply. Total, sorry for the handwriting. Total supply is equals to. So what is the total supply? Here is the supply. Add up all the total supply. I'll get it as 70. Fine. Now let us see what is the total demand. Total demand. So total demand is here. So 20 plus 25 plus 25, it is also 70. So always first check what is the total of all the supplies and all the demands. So when this problem is given, the given problem is balanced because the total supply is equal to total demand, which is equals to 70. So your solution should start with this statement. You have to check whether the problem is balanced or not. whenever a transportation problem is given, the first step is you have to check whether it is balanced or not. To check whether it is balanced or not, you have to check what is the total supply, what is the total demand. If they are equal, that is if total supply is equal to total demand, then the problem is balanced. If the problem is balanced, then you have to can proceed. If it is not balanced, we'll see later how to balance these problems. This is a simple problem, so we are taking a simple one here. In this case, the total supply is equal to the total demand, so the problem is balanced and will move ahead. Copy the transportation problem again. So I've copied here the transportation problem. So now what is happening when I copy this transportation problem? Same thing, demand is here, supply is here. This method is known as northwest corner method for a reason. If you see the map, any map of India or maybe any map which you want, so always remember these are the directions: east, west, north, south. This is the general convention. So where is the northwest side? That is, it comes between north and west. That is, this is the northwest, right? The same logic we are gonna follow here. Northwest is always the top left corner. So in this, consider only the cost matrix. Which is the top left corner? The top left corner is this. What is the cost there? That unit cost is 2. Forget about the cost. Now what is the supply and what is the demand? You have to see. Supply is 10, demand is 20. The minimum of the two has to be taken. The minimum of supply and demand has to be taken, and it is allocated here. This is known as allocation. What I have done here, that is, I have written 10 here. That is nothing but allocation. I have allocated 10 units in this cell. Okay, so once I allocate 10 here, what is the, I have to subtract 10 from here. So I'll write what is remaining. 10 minus 10 is 0, and also 10 from here. 20 minus 10 is 10, and I have to write it this way: 10, then I cancel 10 here also, and it becomes, remains 10. Okay, so this is how our step number 2 comes. I have allocated 10 to the top left corner of the cost matrix. Now what is happening in this case? If you see it, this example is similar to the example which I had given you. Suppose you require 1 kg of rice and you go to the shop. The shopkeeper has 10 kg of rice. How many kg of rice will you purchase from him or bring to your home? Just because the shopkeeper has more, that is 10 kg, will you take all the 10 kg with you? No. It depends upon what is your requirement. Your requirement was 1 kg, so you'll purchase only 1 kg and bring it to your home. So in this case, you are taking minimum of 2, right? Minimum of supply and demand. Your demand was 1 kg and supply was 10 kg, that is, availability was 10 kg. So minimum of those two, that is 1 kg, you bring to your home. That is quite logical. We'll take the other case. You require suppose 5 kgs and the shop has only 2 kgs. Suppose you require 2 kgs of rice and the shop has, sorry, you require 5 kgs of rice and the shopkeeper has only 2 kgs. Then in this case, how many kgs of rice will you purchase from him? Can you purchase 5 kgs from him? No, you cannot. Why? Because the shopkeeper has only 2 kgs. So there is some restriction here from this point. So again, the amount of rice or the quantity of rice that you bring to your home is 2 kgs. That is, minimum of supply and demand. So in both the cases we see that minimum of supply and demand is allocated to you. The same thing we have done here. Minimum here, the supply was 10, the demand was 20. The minimum of supply of and demand is allocated here in this cell, that is the northwest cell. So 10 I have allocated. Now after allocating 10, suppose in the same example I'll tell you, 10 kg of rice was available with the shopkeeper. You needed 1 kg of rice. You took 1 kg of rice and brought to your home. So how much kg of rice do you require more? Nothing. Whatever was your requirement, you have fulfilled it. You wanted 1 kg of rice, you took 1 kg of rice. So how many more kg of rice is required? 0 kg of rice. On the other hand, so you have subtracted 1 from here. On the other hand, the shopkeeper wanted 10 kg of had 10 kg of rice. He has sold 1 kg of rice to you. So how many kg of rice has remained with him? 10 minus 1, that is 9. So same thing we have done. Whatever allocation you do here should be subtracted from supply side as well as demand side, and the remainder is to be returned. So that is what I have done here. Okay. Now whenever, remember, anything becomes 0, any row or any column becomes 0, either that is supply of any row or demand of any column becomes 0, you have to cancel it. Here we can see that it has become 0, right? So we are cancelling this out. So I do not want this in my further calculation. I don't want this row in my further transportation model. The use or usage of this utility of this row is over right now. Now next step, this is what I've done here. The small line which you can see on the top first row, it is not that much visible, but I've cancelled this out, remember, because this was 0. The next step, what is the next step? What can we do once we cancel the top row? Now which is the cost matrix? What is the remaining? The remaining cost matrix is only this much, right? This is the remaining cost matrix. Now concentrate on the top left, that is northwest cell. Which is the northwest cell? This is the northwest cell, right? So your northwest cell is this. Now you have to allocate here. How much you can allocate? Check at the supply and demand of this. Demand is 10. It is 10 now, don't consider 20. The new demand is 10 and the supply is 35. So again allocate minimum of supply and demand. Minimum of supply and demand is 10. So 10 will be allocated there. This is what I have done here. 10 is allocated here and 10 is once 10 is allocated here, you have to subtract 10 from supply line as well as demand line. So that is what I have done here. 35 minus 10 is 25 and 10 minus 10 will be 0. Fine. So now this has become 0. This is already cancelled out row. This also I am cancelling because this has become 0 here. So now what is the remaining cost matrix? It is only this much. So which is the northwest cell? Top left cell out of this rectangle. Top left is this 4 number, right? So there I have to allocate. How much can I allocate? The demand is 25, the supply is also 25. So minimum of supply and demand, that is minimum of 25 and 25 is 25 itself. So 25 I have allocated here, right? So 25 I have to cancel from both the sides, right? Once I allocate 25 here, I have to cancel 25. Don't forget this cancellation. So what is remaining? 0. And what is remaining? 0, right? So this also will be cancelled and this also will be cancelled because both have become 0. A row also has become 0, column has also become 0. so both will be cancelled out. This is what I've done, 0 here, 0 here, and both have been cancelled out. Now what is remaining? Only one cell is remaining. Now here you can see that the supply is also 25, demand is also 25, minimum of supply and demand is again 25, so I have allocated it here 25. So 25 minus 25 is 0, 25 minus 25 is 0. That is what I have done here. So this also gets cancelled here. So all the rows and all the columns should get cancelled in the end, and all the remaining supply, that is supply, should be 0 and all the demand should be 0 in the end. That means all the supply should be met, all the demand should be met, and all the rows and columns should be cancelled. If this is the case, then you have done successfully all the cancellations here. Now next step, what is the next step? Next step is to find out the total cost. Total cost will be equal to, you have to multiply, or you have to check where all you have done allocation. The first allocation is here, the second allocation you can go in any way. You should not remember which you had allocated first, which you had allocated second. That is not the case. You just need to see which all cells have been allocated. So total allocations are 4. So the first one is 10, so 10 into 2 equal to 20. Second allocation is also 10, 10 into 5 equal to 50. Right? 10 into 2, 10 into 5, 4 into 25, and 8 into 25. That is what I have done. Total cost is 2 into 10 here, 5 into 10 here, then 4 into 25 and 8 into 25. So total cost is this. If you multiply and add up, you will get 370 units. So this is your total cost, right? And this is your 5 marks problem. Only one thing I have not shown here is allocation. You need to show the allocations also. That is A, sorry, 1. From source A you are sending to 1. How many items? 10 items. Similarly, from B to 1, 10 items. From B to 2, 25 items, and from C to 3, 25 items. This is how your transportation schedule will be there. So this is the last thing, and the entire problem is solved and shown here. This snap I'll send you on WhatsApp group also. So I hope you understood today's problem. If there is any difficulty in understanding this problem, you can check the video once again, or in the next class I'll take one more problem, and then again if you have any difficulty you can call me between 6:30 and 7 anytime, any day. With this we end today's lecture. If you have any difficulty, please contact me between 6:30 and 7 p.m.